Alright guys, so today's lesson is over what we call the area of regular polygons. As you can see, this top part I already have filled out. It's just kind of definitions and things to help you for this specific lesson for today and tomorrow. This answer key will also be on Canvas, so you can look at that there as well. But basically what you need to know is a regular polygon is specifically a polygon where all sides and angles are congruent. So it's like everything's congruent, all the sides are the same measures, all the angles are the same measures. There's a new vocab word that you would not have heard of before with regular polygons. It's called the apothem. It's this right here. It's the perpendicular distance from the center to the side. So in this situation, this right here, this is your apothem. What you need to know is it bisects both a side that's perpendicular to and the angle that's being created here. So that's what you need to know about the apothem. We'll go more in detail when we do examples. I'm not going to waste a bunch of time on this. You can just look at these definitions on Canvas if you need to. This is common regular polygons, so most of you, I mean, not most of you, all of you should know what like triangle and square is, but you have a hexagon is 6 sides, heptagon is 7, those kind of things. So you know when you are dealing with a problem, you can use this as like a cheat sheet. So what we're going to do before we actually get into finding the area of regular polygons is we're going to talk about finding specific angles, because you're going to need specific angles for different problems to help you with finding the area of a regular polygon. For this example here, this number 1, we have an octagon. Octagon has 8 sides, okay? And inside of it is basically a bunch of triangles here. So you've got 1, 2, 3, 4, 5, 6, 7, 8 triangles. So we're going to find specific angles using what we know about regular polygons. So first of all, this angle 1 is this angle right here. To find that angle, you take 360 and you divide by the number of sides. The way you get 360 is you can think of the fact that you can draw a circle on the outside. So the whole inside is 360. So to get the measure of just this angle right here, and it's going to be the same for all of these because it's a regular polygon, you take 360 divided by the number of sides. So angle 1 would be 45 degrees. Angle 2 is 360 divided by the number of sides times 2. This is the one you will be focusing on for this unit. You will be finding the measure of angle 2 in this section and next section the most. So there's actually 2 ways you can think of it. You can, 1, find angle 1 and divide that by 2, or the shortcut is to get just this part right here. You take 360 divided by the number of sides times 2. So if you take 360 divided by 16, you'll get the answer to be 22.5 degrees. Okay. Again, this one's the important one. Okay. Number of sides times 2. So you take 360 and you divide by the number of sides times 2 to get that specific angle. And then last but not least, to get angle 3, you have 2 now. We just found it. Right here is 3. This is a right angle. So basically use the fact that all triangles add up to 180. So you want to take 180 minus this 22.5 plus 90. So you get 67.5. Again, the important one is angle 2, but you should be able to find the other ones as well. Okay, now for the big part of today. The way you find the area of your regular polygon is you take 1/2 the apothem times the perimeter. So A, lowercase a, is your apothem. And then P is your perimeter. So as you can see here, this right here is the apothem. It's labeled. Perimeter is all the outside. You should know what perimeter is. You take the sum of all the sides. So to find the area of a regular polygon, you take 1/2 apothem times perimeter. Okay, so now we're going to do a few examples to help us here. So let me go ahead and get that over. I'm not going to do all these examples for time's sake, because that can be a super long video, and you guys don't want a super long video. So I'm just going to do probably a few of these ones here, and then you can check specifically my key on Canvas to help you with the ones I don't do, okay? So example 2, we want to find the area of the regular decagon, and we're going to round to the nearest tenth here. Well, the area of a regular polygon is 1/2 apothem times perimeter, okay? We need 2 things to find the area. You need apothem, you need perimeter. Well, they give you the apothem. The apothem is this 12.3. So we've got that. We need to find the perimeter. Well, they give you one side length to be 8. Since this is a regular decagon, all the sides are going to be congruent. So your perimeter is just 8 10 times. So your perimeter is going to be 8 times the number of sides, which is 10. So there's the 2 things you need. Now you just plug them into your equation. So you've got 1/2, apothem is 12.3, perimeter is 80. Put that in your calculator, and you get 492 inches squared. So that's basically the main idea on how you find the area of a regular decagon. This is as simple as it gets. It gives you everything you need, okay? But in general, you just need to remember you need 2 things to find the area of a regular polygon. You need the apothem, and you need the perimeter. Okay, so below, we're going to look at number 3 and 5 specifically. 4, you can check my work on Canvas to see how to do number 4. But I'm just going to do 3 and 5 below. And then you will have a worksheet that will be your work for today. All right, so number 3, we want to find the area of all these regular polygons. And specifically in number 3, what we have is a hexagon, because you've got 1, 2, 3, 4, 5, 6 sides. Now the problem here is we know to find the area, we need 1/2 apothem times perimeter. Well, we can get the perimeter because we know that one side is 8. We cannot get the apothem. So what you have to do, anytime anything is missing, you are going to be drawing it in. So we need to specifically draw in our apothem because we're missing our apothem. So that would be this right here. To help us get this apothem, we're going to create a right triangle. So what we have at this point is we have a right triangle. Now, remember, the apothem splits its side in half. So these 2 parts are now both congruent. Since the whole side is 8, each are 4. So you have a right triangle right now where we need the apothem. You know this side is 4. Here's what you need to get. This is the key. And you're going to be doing this every single time you do one of these problems and you have to find something. You have to find this angle right here. So this angle right here, that was like angle 2 on the front of this note sheet. And the way you do it is you take the number of sides times 2 divided by 360. So you take 360 divided by number of sides times 2, which is 12. So this angle specifically is 30 degrees. Why that's important is because since this is 30 degrees, this angle right here, you now have a 30, 60, 90 triangle. So if you were to draw it out to the side, if you wanted to, this triangle looks like this. Where this is 4, this is A, that's 30. Okay, so this would be like 60 degrees. You have the short side, you need the long side. If you need to, go back to your special right triangles. We did that before spring break. But basically, A, which is the long side, is going to equal 4 times the square root of 3. So your apothem is just 4 square root of 3. Okay, do not multiply those out. There's no rounding. You're leaving it an exact answer. So your apothem is just this right here, 4 square root of 3. Okay, your perimeter then is the number of sides times the length. So we've got 8 times 6, which is specifically 48. So now that we have the apothem and the perimeter here, we can get our area. So our area is 1/2 the apothem, which is 4 squared to 3, times our perimeter, which is 48. What you need to do is you multiply the 4, the 48, and the 1/2. Okay, so when you do that, you get 96, and then you attach on the square root of 3 meters squared. No rounding. If you're getting decimals, you're doing it incorrectly. Do not round. I'm not going to do all of number 4, but I do want to say something about 4. Actually, I'm going to do this with 4 and 5. If you can make your life easier, guys, make your life easier. So for number 4, what you have is specifically an equilateral triangle, meaning all of their angles are 60. All these are 60. You can find the area of this by taking 1/2 base times height, like a triangle, by drawing in your height, because this is 10, this is 30, this is your height. Since this is a 30, 60, 90 triangle, you know this is 5, right? And then your height is your long side, so your height ends up being 5 squared to 3. So when you can make your life easy, make your life easy. So then the area here ends up just being 1/2, the base is 10, and the height is 5 squared to 3. So you end up with 25 squared to 3. I guess I ended up doing it. Sorry. Well, oh well. And then last but not least, number 5. Number 5 is a square. And once again, I'm going to tell you this, when you can make your life easier, make your life easier, okay? Now, you do not need to use the regular polygon equation for number 5. The reason why is because a square is multiple shapes. You learned this in Geometry 1. A square is a rectangle, a square is a parallelogram, a square is a rhombus, a square is multiple things. In this situation, there's something that you know about a square, and that's that its diagonals bisect each other and are congruent, which means all these are 20. Well, if a square is also a rhombus, because it is, you can use the area of a rhombus to solve this problem, which is 1/2 diagonal 1 times diagonal 2. Which is way easier than using the regular polygon equation, because you'd have to find all the missing parts. Well, we have the diagonals, right? The diagonals are going to be the same. They're both 20 plus 20. So both your diagonals are 40. So you could use that for the area. So you've got 1/2, 40 times 40. So when you take 1/2 times 40, you get 20. 20 times 40 is 800 millimeters squared. All right, so that is the notes for today. You are going to be having a worksheet that you'll be doing on your own to get some practice with regular polygons. You need to make sure, if you have to, go back and look at special right triangles, because those will be showing up in some of your problems for today. Okay, so that's all for today. Have a good day, guys.